Ever since humans mastered the skills of throwing stones and boiling water, we have basically conquered the flat surface of the Earth. However, very few have ventured into the vertical space. Why is that? Anyone who has studied in high school knows that shooting things into the sky is never easy because you have to work against gravity. If we put this in the context of a Xianxia cultivation world, gravity would be like an ancient restriction placed on Earth, firmly trapping humanity. So, if you want to leave Earth, you first have to see if Newton will allow it. But who are we? We are the terrifying survivors who have endured for 0 years braving water and fire, working across all 7 continents, toughened and hardened by venturing to the heavens and the depths of the Earth. So, of course, we have to take on Earth's vertical space as well. And, look, April 24th is China's Space Day. From the successful launch of the Dongfang 1 satellite on April 24, 1970, to the launches and subsequent docking of the Wentian and Mengtian laboratory modules with the Tianhe core module, it has taken us only 52 years to fully complete our own space station. This is the uniquely Chinese romance of our space program, and we have every reason to feel a little proud. Although our progress has been remarkably fast, the hardships along the way are easy to imagine. Aerospace is different from aviation. Generally, activities within the atmosphere are called aviation, while those beyond the atmosphere are called aerospace. Aviation is very simple. Just how simple is it? It's said that as early as 1970, the Soviets developed the MiG-25 fighter jet, basically made by slapping stainless steel with a diode radar and rocket engine. It was a rough design like adding water when there's too much flour, and flour when there's too much water yet. It could fly at Mach 3 at 30, 0 meters. But once you want to leave the atmosphere and enter spaceflight, it's a different story. The difficulty increases dramatically. As everyone knows, to launch a spacecraft and overcome Earth's gravity so it doesn't get pulled back, you need at least the first cosmic velocity, 7.9 kilometers per second. To completely escape Earth's gravity, you need at least the second cosmic velocity, 11.2 kilometers per second. And if you want to completely escape the sun's gravitito, truly reach the stars, and the sea, you need at least the third cosmic velocity, 16.7 kilometers per second. You should firmly remember these 3 velocities. You'll need them when it's time to move to a new home in the future. All of humanity's fireworks, in the face of these 3 iron laws of spaceflight, are as immature as a rookie soldier. Currently, the mainstream way to reach space is still through chemical rockets. As we mentioned before, chemical rockets are really underwhelming. 90% of their weight is just fuel and oxidizer, with less than 10% left for the actual payload. It's like a small horse pulling a heavy cart, truly the case. In addition, chemical rockets have extremely high acceleration. What does it feel like to ride a rocket into space with 9 Gs of acceleration? It's just like riding a rocket with 9 Gs of acceleration. Only astronauts with exceptional 1 in a million physical fitness can withstand it. If the acceleration were any higher, even the most elite warriors of the Tang Dynasty would probably be torn apart. Let alone ordinary people, they'd be reduced to a slushy mess. But if regular people can't enter space on a large scale, then who's going to build the future space cities, spaceports, and interstellar warships? You might ask, when will the kind of Chinese-style sci-fi I've seen in domestic works like The Wandering Earth or Earth Blasts Off actually become reality? Of course, at this stage, if we want to experience that kind of Chinese sci-fi in the universe, for now, we can probably only do it through games. After doing a quick search, I found that in the newly released Mars Biohazard map in CFHD, you can see safety first, prevention oriented, and danger. High voltage signs everywhere. If there were really a Mars base, you'd immediately recognize it as the handiwork of a certain Eastern infrastructure powerhouse. In addition, things like the Sitchin space mecha and space warships easily remind people of real-life spacecraft such as the Zhihe, Wentian, and Mengtian. However, from a realistic perspective, the key to building such a Mars base lies in finding a way for ordinary people to travel to space on a large scale, no longer relying on rockets, which use primitive propulsion systems based on oxidizing propellants. So, is there a more efficient method? Yes, there is, my friend, there is. In science fiction novels, there's something called the Earth Cannon. You dig a tunnel through the Earth and make it a vacuum at the start. You jump in from one end, and in the second half, add a strong magnetic field. Then, you wrap the spaceship with an electrified coil, using reverse electromagnetic force to counter gravity. This way, when you shoot out the other end, you can reach the first cosmic velocity and enter space. The acceleration in the first half is only 1 G, and the second half is uniform motion, so ordinary people can handle it. However, this method is like drawing a knife from the dragon's path. It's theoretically possible, but in reality, completely unworkable. When we talk about reaching the sky or going underground is much harder than going up. If we compare the Earth to an egg, the deepest hole humans have dug so far hasn't even pierced the eggshell, let alone drilled through the entire Earth. Besides, what if you end up digging up something like Skull Island's Kong? What would you do then? Another method is the space elevator, which we're all quite familiar with. The advantages of a space elevator include, first, it's safe and comfortable so people can travel to space. Second, it moves materials and staff. However, there's really only one drawback: it simply can't be built. Just the materials alone are a huge bottleneck, and we don't have the kind of high energy density needed to transport the elevator cabins. We probably have to achieve controlled nuclear fusion before we can even talk about it. Of course, in theory, there's also a third method: the space battleships that often appear in many science fiction works. Not only can they carry a large number of people, but they can even achieve space jumps. Space jumping is a godlike technology of advanced civilizations. There's no way it could be realized in reality. It's just something to imagine. But there's no need to worry. When Dao Long was goofing around at the Mars base in CFHD, he accidentally triggered the weapon inspection mode, and right before his eyes, the gun in his hand transformed into the shape of a starship. The starship is modeled after traditional Chinese architecture, surrounded by small rotating energy halos, and the gun itself is adorned with winding, illuminated energy patterns, giving it a distinctly Chinese sci-fi vibe. The other two mythic level sets can also transform into different starship forms when in inspection mode. It seems that the appearance of the Battle Pass series skins is also designed with a Chinese sci-fi concept in mind. One of the guns features a blue and white color scheme, and in inspection mode it looks as if a satellite is flying into space and projecting a hologram. The other one, White Steed Asking the Heavens, has a design and special effects that also recreate the scene of a rocket launch. Of course, all these things mentioned above are still impossible to achieve in reality due to the limitations of materials science and energy science. If we solve either materials or energy, that would mark the beginning of the next era. If we solve both, humanity could step into a Type 1 civilization. Perhaps only then will our journey to the stars and the sea truly begin.